Okay, this is the classwork for night 7, continued for the third part, I believe it is. And we are, in this one, going on from our slope, which was the negative reciprocal, back for problem number 3D. And now we're going on to problem number 4. So problem number 4, we have this line graphed here. I've graphed it on here, and we want to find the slope. When we have a graph of a line, the easiest thing to do is to find the slope of this line visually. So we're going to see from how to travel from this point here over to this point here. So we're going to go down 1, we're going to go down 1, 2, 3. And so our rise is a -3. So I've gone down, so that indicates a negative. And then from there, I'm going to go over. That's 1, 2, 3. So that's my run, and I've gone to the right, so that indicates a positive value, so that's a +3. So I have my rise and my run, and my slope is indicated by my rise over my run. So my -3 over my +3, which simplifies down to -1. Now remember that this isn't the only way that I could do this. Remember, I could also start at this point, and I could do a rise of 3, and I could do a run of -3. So this would be positive, and then this one would be -3. And remember that it doesn't matter, because that still gives us positive divided by a negative, which is still the same thing, a -1. Okay, now problem number 5 says that we want to find this, the equation of a line that's parallel to this one in 4. So parallel, it means that we have the same slope. So the M parallel is one of the things that we need here. And M parallel means that the slope is also a -1. And then from this one, we also need this to have through the point 0, -2. Well, when the x is equal to 0, then we know that that's the y-intercept. So we know our y-intercept. So all we're going to do is we're going to plug in our slope, we're going to plug in our y-intercept to get the equation. So y is equal to -1 times x, and then plus a -2, or you can write as -2, however you wish to. This is the more sophisticated version. Plus a negative is the same thing as subtraction. So -1 -2, -1x -2. Now also remember that it is perfectly acceptable to take that away and just have -x -2. Either way you do it, it's 100% correct. All right, on to problem number 6. This problem number 6, what we want to do is we want a vertical line through 7, 8. So we have to remember that a vertical line is an x equals line. So we're going to say, oh, x equals. And the thing that we need to remember is that all ordered pairs in vertical lines have this x coordinate right here. So our vertical line's equation is x equals 7. Quite easily done. All right. Next, we're off to the more complicated problem. This problem is one of our linear equation problems. So remember, unit analysis is good for these. So one of the things that we might want to do for unit analysis on this problem is that we might want to start with the slope, because remember, the slope having a rate of the rate of change being the dependent over the independent, that's kind of a dead giveaway of that one. So let's read the problem. A person weighs 195 pounds when he or she begins a weight loss program. After beginning the program, he loses 4 pounds per month. See the pounds per month? That's a ratio of units. So what we have going on here is pounds per month. And that's telling us that this thing is our rate of change. But that also tells us that our dependent value is going to be pounds, and our independent value is going to be months. So that kind of nails down these. And so it says, let W be his weight loss in pounds, T months after he's begun the program. So we know that the dependent, the W, is equal to the weight in pounds. Now I'm going to run out of time here, so this will be continued in the next one. So we'll pick up with the independent there. So we have weight in pounds, and